gelral Codeforces Educational Round 2E. This is the first. So I just recently read about DSC on trees, and this is the first question I've solved on this topic. Uh, so the question is that we've been given a tree, and each node has been assigned a color. So for each node, we need to find the sum of all dominating colors in the subtree of V, and we define dominating color as the color that occurs the most number of times in the tree. And if there are two or uh, yeah, so and if there is one color that occurs the maximum number of times, then it will just be that color. We need to just report that color. Uh, otherwise, if uh, otherwise if like for example three colors occur f number of times in the subtree, then we need to report the answer as color 1 plus color 2 plus color 3. Yeah, this is a problem statement. Now uh, first of all, the structure we will maintain is map of int comma int star mpn. This is basically, so one thing we need to remember while dealing with DSC on trees is that we always use pointers, because the whole idea of DSC on trees is to be able to um, use small to large merging technique, and for that we need pointers, because if we don't use pointers, then we'll end up with order of n copies. What I mean to say by this is, uh, okay, we'll see an example. So let's say this is the situation we have now. To form to form the structure for this node, we won't copy all these elements. We'll copy all these elements, like all these elements. That is true. But to form this structure, we don't need to copy this elements, these all elements. We'll just copy the pointer of this structure. We'll initialize the pointer of this structure to the pointer of this structure, and then copy all these elements. So the number of copies made is equal to number of like elements in these nodes, in these children subtrees. Okay, and one more observation is from the small to large merging technique. Uh, to find what is the complexity, let's for now focus on a single element. Let's say we have an element. Uh, let's say this is the tree. Uh, okay, let's say this is a single element. We will only copy this only if this node is present in the smaller uh, child. I mean, is one of the smaller children of this particular node. So let's say this had three children nodes. This node. So this would have had to be, so from size 1 it would have gone to size 3. I mean, from a set of size 1, this element would have gone to a set of size 3. Okay, now if this has to be copied, then the other children must be I mean, at least one child must be of size greater than 3. So in this way, uh, it will be uh, okay. So at least, so this would be 2. At least one child has to be greater than size 2. So the minimum size of this would be 4. And if we carry on this way, we see that a single element can be copied at most log n number of times. And depending on the structure we use, the complexity of copying, let's say we are using a set, the complexity of copying itself is log n. So for a single element, we need log square n number of operations. Okay, once this is out of the way, Yeah, so from this complexity analysis, we can see that the whole DFS traversal would take order of n log square n time. Okay. Now moving on to this question, we had, as we had discussed, this structure we need to maintain MP, where MP node of C would give us the frequency of color C in the subtree of node, and uh, also will maintain a structure called DP of B, where DP of B is basically it stores the maximum frequency comma color pair uh, in the subtree of B. So by B I mean in this case, I mean DP of node would store maximum frequency color comma color, or rather sum of colors with this maximum frequency. Okay, this would be stored by DP of node, and to uh, formulate DP of node, we need the value of DP of big child. We need this structure. Okay. Now the way we solve this is, first of all, uh, okay. So we'll we have MP big child already. Since we are populating this in the DFS traversal, let's say we already have the MP big child value with us. So we'll initialize MP node to be MP big child, and then we'll add all the values from these children to MP node. Once that is done, we see that all the colors have been covered. Sorry, all the colors that are present. Uh, okay, no. MP node. So first MP node is has been filled. Okay, this has been maintained. MP node. Now we need to find the answer, and the way we find the answer is by iterating. Uh, we'll iterate through all the non-big children of node. So this is the big child, and all of these are non-big children of node. We'll iterate through all the non-big children of node, and for every color that occurs in the non-big children of node, we'll see whether whether the frequency of occurrence of this color is the maximum. If yes, we'll update the answer. If no, we'll continue. So this way, we'll be able to store. We'll be able to get the information of all the colors that occur in these nodes. But let's say there's a color which occurs only in big child, but not here. That would be taken into account uh, from the uh, from the iteration on non-big children of node. So that we'll have to handle separately. And okay, let's see. This Let's take this example. MP DP of big child. This big child DP of big child is 4 comma color, 4 comma red. Okay, and okay, yeah, okay. And MP of node before. So this is when we initialized um MP of node to be MP of big child. This is from that. So red would be 1, 2, 3, 4, 5, 6. 6 red, 0 blue, 1 green, 0 peach. And once we do the traversal, that would be MP node now represents everything. That will be 6 are 1, 2, 3, 4, 4 blues, 1, 2, 3, 4 greens, 2 peaches, and 1 gray. Okay. Now this is what I was talking about. The maximum, if the maximum color only occurs in big child, we need to handle this case separately. We need to check this case separately. Uh, okay. Also, another observation is we need to check for node also separately, because when we iterated over the non-big children, we didn't consider the color of node. That will also be need to that will also need to consider separately. I think looking at the code, things might be a little clearer. DFS1 is nothing but the plain DFS to calculate subtree sizes and the big child of every node. This is about DFS1. DFS is the main function. First of all, we'll do a DFS on the children. If the big child of, if basically node is a leaf node, we need to initialize the map. Otherwise, we copy the pointer. So this is what I was talking about. The reason why I need to store pointers instead of like normal structures, because otherwise this would have been order of number subtree size of big child operation. But here it is only a order of one operation. Yeah, and this is handling the this is handling the node, and this variable is for storing what I just spoke to you about, whether this color is occurring in all of these children or not. So this variable handles that, and highest frequency, yeah, and current best is the like the answer we have stored till now. That will keep updating this as we iterate through all the non-big children of node. And so this is, so if color, if if this color of node has been found in any of the non-big children, we'll set this variable to be 1. If the color, if the frequency, the matches of this color matches the maximum frequency, we'll just update the uh, sum of color values of this frequency corresponding to this frequency. We'll update this. Otherwise, if the frequency of this color exceeds the current best frequency, we'll update the answer. Now we need to handle separately the case when node's color, uh, when the node's color was not occurring in any of the leaf, any of the nodes, non-big children. So if that is the case, we'll see whether the color of node, so whether the color that the color of the node has, whether that color occurs more than the current best answer. If yes, update the current best answer. If no, if it occurs exactly the same number of times, we need to add the frequency. We need to add the color value to the answer, and yeah, and the reason this is okay to do is because since we are in this condition, we already know that this color was not occurring in any of the uh, nodes non-big subchildren, non-big children. Yeah. So hence this is safe to do. Yeah. And if this is a leaf node, just return the answer. If this is not a leaf child, we need to like so note that current best still does not consider colors that are only present in big child. So we need to consider those colors as well. So big ch answer is the uh, answer from big child node that we got from like from the DFS traversal we did here. So we already have this answer with us. If this the frequency from big child is greater than the current best, update current best. If the frequency of from big child is equal to current best, then we need to add the color value to the current best sum of values, because again, uh, there's no way that uh, this color, the optimum color from big child, has occurred anywhere, uh, in the other non big child subchildren or the node as well. And we finally report the answer. Yeah, this was kind of complex, but this is the answer.